Hey guys, welcome back to Maths from my desk, and in today's video we will be proving that the square root of 2 is an irrational number. So first what we're going to do is we're going to assume the opposite. So this is going to be a proof by contradiction. So let's suppose that the square root of 2 is rational. That means that we can write the square root of 2 as a fraction a over b, where a and b are both whole numbers and the fraction is in its lowest terms. So that means a and b don't share any common factors, meaning that a and b aren't even, because if they were even, then you could divide them by 2. So now the next step is going to be to square both sides. So if we square both sides, the square root of 2 squared is just 2. A over b squared, that's just a squared over b squared. And then the next step now is going to be multiplying both sides by b squared. So we get rid of the b squared in the denominator here. And then what you end up with is a squared is equal to 2b squared. So what this tells us right here is that a squared is an even number. This is because it's equal to 2 times something. If a squared is even, then a itself must also be even. So we now deduce that a is even. And so we can go ahead and write a is equal to 2k. This is true for any even number, where k is some integer. And we're going to go ahead and plug this back into the equation a squared is equal to 2b squared. So we have 2k squared is equal to 2b squared. This ends up simplifying to 4k squared is equal to 2b squared. Then we divide both sides by 2, and we have 2k squared is equal to b squared. So now we have just proved that b squared is also even, which means that b is even. Once again, this is the same reasoning, because b squared is equal to 2 times something. So to 2 times something. So we have deduced that b is even. And now here's the problem. If we go back, we said that if the square root of 2 was rational, then it would equal a over b, where a over b are not even, are odd numbers. We just proved that both a and b are even. They share a factor of 2. That contradicts what we said earlier, that the fraction was in its lowest terms. So our original assumption, this one right here, is false. And that means that the square root of 2 cannot be written as a fraction, or in other words, the square root of 2 is irrational. Thank you guys for watching. Please like and subscribe, and I'll see you soon for another video.